have another example, try to identify the zeros of this function, but also too, I'm curious about its multiplicities. So how do we determine that? Well, we solve for x's, and right now what we can look at is we know that for this to be true, for this middle term, if that were equal to 0, this entire function would equal 0. And likewise, if this last term, the 2x minus 3, if that equal to 0, that entire function would equal to 0. Don't have to deal with the 1/2 because I know that if this middle term were a 0, it would equal 0, and likewise if this last word. And that's because they're all products of each other. So x plus 1 equals 0. That's true when x equals -1. And this is true when 2x equals 3, x equals 3/2. And that's true when x equals 3/2. So what do we know about the multiplicities of these? Well, -1 is a multiplicity of 1. There's only a power 1 there. However, this 2x minus 3, well, there's really 2 of those. And so with that, I have a solution of x equals 3/2 with multiplicity of 2. What does that mean for us graphing it? Or what does that look like if we were to graph this? Well, let's just draw just a quick generic graph. I have small points, 1, 2, 3, 1, 2, and 3. I know I have a solution at -1. I know I have a solution at 3/2. I can look at my end behavior. My end behavior tells me that I have an odd graph, x to the first, x squared. So I have an odd graph. It's a positive. So I have some end behavior that starts down this way and ends up that way. All right, how do we connect the dots? What do we do with this particular case? Well, I know that x equals -1. -1 is a solution, and it's a multiplicity 1. So I know I have a graph that crosses at that particular point. This other solution, 3/2, it's multiplicity 2, which tells me that the graph just touches at that point and turns around. And there, I have enough information to kind of fill in the gaps of what the rest of the graph would look like. I'm going to try to draw it as smooth and continuous as I can, because our polynomial functions are smooth and continuous, but this graph tells me it's an odd graph, so it rises from left to right. I cross at -1 because it has multiplicity of 1. At 3/2, it's a solution, but it's a multiplicity of 2, so it doesn't cross. Rather, it turns around and bounces off of the graph at that point and continues to increase without bound as x becomes greater.